Video for the topic 5 assessment, the review, the Form B. And before I even get into this, I want you guys to pause this video, get out some paper, and be prepared to take notes, because the stuff that we're going to be learning on this has cool applications for the pathway that you're in, but most especially for this test. So get out a piece of paper and get ready to do some note taking. It's not very long, but it's very important, because what we are going to be talking about with this lesson is our 4 centers of a triangle. So you're going to put topic 5, notes. And we're going to put centers of triangles. We're going to have 4 pictures, 4 different types of them. One is called the circumcenter. One is the incenter. Leave good space because you'll want to draw a picture and have words. In center, we're going to have the centroid and the orthocenter. And we're going to put in a description, and then we're going to draw a picture, and then we're going to look at it more using an app or using an application, a computer-based application. So the circumcenter, what the circumcenter is actually, I need to draw it. Okay, if we had a triangle, and it can be any shaped triangle that we want it to be, just a triangle. Draw a triangle. If yours doesn't look like mine, it's totally fine. What the circumcenter is it is the point where the perpendicular bisectors meet. What that means, perpendicular means they cross at right angles. Bisectors means that they split the section exactly in half. And then meet is like the intersection. So on my triangle, how I would ish that is I would take one of the sides. So if I took this side right here, I'm going to kind of like eyeball about where half is. And then I'm going to try to draw a line that looks like a corner of my piece of paper could go into there. And then I'm going to mark it with a square. I'm going to do that to each of the sides. So this other side right here, about half looks like it's right there. Pretend like my corner of a piece of paper went into it, like that. Now, there are fancy ways of doing that, of doing this art that I'm doing now, but we don't need to do it right now. Let's see this other one. 1, 2, 3, 4, 5, 6, 7. Oh, so 3.5. So like here is halfway, and I want them all to intersect. So that would be right there. That'd be right. So these are all the perpendicular bisectors that I drew. So circumcenter has to do with the perpendicular bisectors. Let me tell you an advantage to the circumcenter and why this applies to your pathway while you're writing your notes. You don't have to draw this part. It's just really nice to know. So if you were to be in charge of some sort of project in anything, we're talking like decorating for a catering event, we're talking construction, we're talking even like speaking to people evenly, if you like maybe were a leader in a medical field, or even if you were talking about social distancing. If you wanted to have, let's say you had 3 different points and you wanted everybody to be the same, like you wanted one thing that was going to be the same distance from everybody, then what you would do is use the circumcenter. What the circumcenter does, the advantage to a circumcenter, is it allows, if you were to draw a circle, you could circumscribe a circle. That means draw a circle, right? That would go through, the center would be the circumcenter, and it would go through and it would intersect perfectly all of the points of the triangle. The circle would technically keep on going down and be approximately there. You don't have to draw the circle. I'm drawing it just for the sake of me saying it. So that circumcenter would be like, we're talking all of the vertices man, I know I spelled that wrong. Vertices would be equidistant. Do you guys know what equidistant means? It's equal distant. So equidistance. But that would help with so many different situations. So that's a real life application of that, but that's the circumcenter. The things that you need to know is the circumcenter is where the perpendicular bisectors meet, right? The next thing, so if you needed to pause the video and write that down, you can. The next one is the incenter. I'm going to draw, again, just a triangle. Like this. So the incenter, so the perpendicular bisector had where they were perpendicular and a bisector. The incenter instead it's the point where the angle bisectors meet. So, and this is where it's kind of tricky. So I look at one angle. So like maybe I'll look at this angle and I think, okay, where would I split that in half? Oh, it looks like it'd be about right there-ish. And then same, so that this angle and that angle are the same. Then this one over here looks like it'd be about right there and right there. Oh, nope, maybe down a little bit more. Like right there and right there. So that this angle and that angle are the same. And then this other one, oops. Okay. This other one, so it's about halfway between again, right? So there are really fancy geometry ways. We call that constructing, which is another word for drawing that. So this is the incenter. So it's, and what I did right here, so there's an angle right there, 1, 2, 3, is going to be the same as that one, 1, 2, 3. So all those little tick marks meant that they were the same. Ooh, speaking of tick marks, I'm going to come back here. What I would show on this to show that that was the bisector is on one side, like this half that I put one tick mark on would be the same as the one on that half. Or this one, this half would be the same thing as that half. Or this half, oops, 3 lines, would be the same thing as that half. That's what those tick marks mean. And those details are very important, especially like medical sciences. Actually, everything, all of your fields need details, paying attention to details. So those details matter. And what the details matter with this are those little tiny tick marks. Like there's one on the top, 2 tick marks on the one on the left, 3 on the right, showing that they were angle bisectors. And that point right there is called the incenter. So let me tell you an advantage to the incenter. One of them is if you were trying to, if this was like, I don't know why you would have a piece of dough like this shape, but if you wanted to figure out what's the biggest circle that you could cut out of this piece of dough, that is what the incenter would help you find. You'd find the approximate like angle bisector of each of those vertices. And then this is called, so this circle is called an inscribed circle, which you don't necessarily need to have again. Just like this one, this is called a circumscribed. A circumscribed triangle. because the circle was scribing around the triangle. Anyway, you don't need to know those words. That's not part of the vocabulary. So we have the inscribed circle. So the incenter is where the angle bisectors meet. Then we have the centroid. So the centroid, again, I need to draw a triangle. I will try to draw one a little bit different maybe than I did the last ones. Yeah. Just for the sake of being exciting. Okay, a centroid is the point where the medians meet. And if you're a normal person, you'll be like, wait, what's a median? It is you're connecting the midpoint. Do you guys remember midpoint? Of one side to the opposite vertex. Okay, so let me show you what that looks like. So midpoints. So I'm going to focus on this side, about halfway, and there again are fancy ways of doing halfway there. So this is the midpoint of that side, and the only vertex that it could possibly connect to would be that one. So this right here is the median of that side, where this side is congruent to that side. Now I'm going to do another side. If we had this one right here, then about right there is the midpoint, and it's going to connect to the opposite vertex right there. So this half is congruent to that half, and my pictures may not be accurate. That's okay, because I labeled it with the accuracy. That's the cool thing about geometry, is even if it's not perfect, if you label it like that, it has to be. Okay, and then so that looks about halfway. So this half is about the same thing as that half, and it's going to connect to the opposite vertex. And that point right there where they meet is the centroid. And this is cool because it's a place where like you could balance. If you had a triangular rock, you could balance that rock on the point that's the centroid, and it would stay balanced. It's really cool. There are other applications, but that's just the one that we're going to talk about. And then the last one is of these four. So we talked about the circumcenter, the incenter, the centroid, and the last of these, and this is the last one for this part. Oh, the centroid also has other things that we're going to talk about. But the orthocenter. The orthocenter, I'm going to draw another triangle. Like this. So the orthocenter is where the point where the altitudes meet. And you might be thinking, well, what's an altitude? It's the height. But you can probably see that if we had this triangle, no matter how we took this triangle and turned it, like the height for this one right now, as it is, would be from the vertex, like from up here, and it would be perpendicular with the horizontal, right? But if I were to take this same shape and turn it, so let me show you that. If I were to take this and turn it so another side goes straight down, then this one right here, so that line right there going straight down, would be the altitude for that direction. Or if I were to take it again and turn it again, if it were like this, then from that vertex straight down would be the altitude that way. So this point where they all meet, or two altitudes meet, that doesn't look like it works, does it? Yeah, I think I had that one crooked. Let's do undo. Okay. I think I had it a little bit crooked. Actually, I'm going to undo the turning of it. Okay. And then I'm going to move it down, and then I'll turn it. Yeah, that looks better. Something like that. And also my lines may not be perfect. So it would come down. So we would have the distance. Oh, okay. We'd want this distance from there to right there, and that would also be right. So those are the altitudes. It's the height of the, and so it needs to be perpendicular, and it's not going to be the midpoint. You'll see, like, I'm going to move it back to how it was. That none of these, and I said that weird 3 thing went with it. None of these, okay. None of those were halfway, right? Like would you agree with me that this point right here was for sure not halfway? But those were the altitudes. So that's the orthocenter. Sometimes that point, the orthocenter, centroid, and incenter and circumcenter can be the exact same point. But yeah. Orthocenter is a place where you could put something for the structure, like it's important for structure in maybe cake building or construction, right? Okay, so those are the 4 things. If you did not write those down, then write those down. And yeah. Okay. Oh, and let me tell you, the other thing with the centroid that's really important to know is with the centroid. So we're going to come in and zoom in on the centroid. And with the centroid, if you looked at this point right there, would you agree with me just looking at any of them? It is not halfway between, like if you looked at the median. So if you looked at this median right here, it is not halfway between that median. Well, that's a thing. And in fact, there's a very specific thing with it. It says that if we knew that this length was 1, then this length right here would be 2. So the whole thing would be 3. And what we end up with is 3 different pieces. We have a small, which I'm going to call it like X. Then the medium would be from the centroid to the other peak, would be like 2x, twice as big. And I'm going to call the other one large, and that's going from over here all the way across. That would be 3x's. So, and if I didn't say x, like maybe instead of 1 and 2, it was like if the small one was 5, right? If our small one was 5, well, then our medium one would be 10, and our large one would be 15, right? Or maybe instead they give us details like, what if the medium one was 12? What's the large one? And there's fractions that you can use to do this. You can work around it though. So what I like to do is if they said, what is the large if we knew the medium was 12? Well, I know that I can go back to the small one. I know the small one would be half of that, so that would be 6. And then the large one would be 3 times 6, so that would be 18. So you can use that a lot, going back and forth, and that's going to help us on some problems. So we're just going to start with these. When we're doing the review, you'll notice that these words, these vocabulary words, are going to come back up a lot. So keep this paper available to you when we go back and do the review, which I'm going to do right now. Okay, so we're coming back into the review. To construct. So we're going to kind of break this down. When it says construct, that's a fancy way for us. Like there is construction, but in this case, we would mean draw. The inscribed, you guys recognized inscribed circle. So let's go to inscribed circle in our picture. So inscribed circle. Hey, look at that, inscribed circle. So the inscribed circle had to do with the in center, right? And that had to do with angled bisectors, right? We need to look at all those things. So we're going to come back up here. So it says, if we were to draw the inscribed circle, so maybe I'd put up here, in center, angle, bisectors, meet. So you must construct at least two of the angle bisectors, right? We wanted the angle bisectors of the triangle to find their intersection point, which again would be the incenter. And then it says draw a perpendicular line from this point and set your compass to measure. So let's see, if they were to intersect, we know that the angle bisectors intersect at the incenter, right? So look here, incenter, and right here's the word incenter. So you're going to set it to be the length of the incenter. And then place the point of, from the incenter to the perpendicular thing. And then again, here's incenter. And then that would be your answer to that one. Which, you don't have to know how to draw it. The main thing that we were looking up is incenter and angle bisectors, right? They all had to do with each other. So there might be a problem on the test that had to do with another one of these and like the constructing of another one. But you're gonna again look at all the vocabulary that we used down here. So we said incenter went with angle bisector and inscribed. Circumcenter went with a circumscribed triangle, had to do with perpendicular bisectors, had to do with equidistant. Centroid had to do with the medians, and then, centroid had to do with the medians. Orthocenter had to do with the altitudes, like they're all related, right? So just make sure you have those words down. Okay. Now, number 2 is not directly at all actually related, other than it's a triangle related to this. So, number 2. Do you guys remember how many degrees, if I just had this whole arc right there, like from there to there, how many degrees that is? You might remember, hopefully you do, that it was 180 degrees. So if I wanted to find this half on over here, I could just subtract 87 and I would get 93, right? So that would be 93 degrees. And it's asking what's true. Now, AB, how does AB compare to BC? Now, let's just kind of like use some logic. Looks like everything else is the same. We're going to pay attention to these tick marks. This tick mark, pardon me, and that tick mark show that this AD is the same thing as DC. And then the triangle on the left half and the triangle on the right half, or not approximate half, share that line right there. So really the only difference now is the angle. So which side do you think is going to be bigger? The one across from 93 or the one across from 87? What do your spidey senses tell you? And if your spidey senses are like mine, it would say that AB is the bigger one. And that's actually a thing. And so this is what I want you to put is greater side across from the greater angle. I should put opposite. Or across from. Angle. You can pause the video if you need more time to write that. Okay, so that's kind of I like this one because it made sense. Look, bigger side. And even if you didn't want to do the calculation, if you just say like, this side looks bigger, then go for that, right? You didn't probably even need to know that it was 93. Just know that 87 is less than 90. And so what's not perpendicular, so the other side would have to be bigger, right? I did talk about circumcenter, but we didn't need a circumcenter, right? I didn't ask anything about the circumcenter. In fact, circumcenter has to do with perpendicular stuff, and there's nothing perpendicular on this, so I'm going to put no perpendicular. And then bisecting, this bisected the angle, but not the side. So that one's for sure not true.